So in this problem, we want to determine the electron pair and molecular geometries for XeF2. Before we can do that, we actually have to get our Lewis structure first. So that's going to be the first thing we need to worry about. And in order to find the Lewis structure, I first need to figure out how many valence electrons I have in my molecule. So for xenon, I have 8 electrons plus 2 times 7 from each of the fluorine. And so what I get is a total of 22 electrons in my final structure. So I'm going to draw my skeletal structure with single bonds, remembering that fluorine always is a terminal atom. Now I've got used up 4 of my electrons. I have 18 left. I'm going to fill in the octet around each of my terminal fluorine atoms. Now that I've done that, I've used up 16 of my electrons. I see that I still have 6 additional electrons left, so I'm going to put those on the central xenon atom, and now I can see what my Lewis structure is for my molecule. Now that I know the Lewis structure, now I can look at the Vesper form of the molecule. So I have Xe, which is my central atom. We'll represent that with an A. Then I have 2 bonding groups, which we represent with an X. And then around our central atom, we have 3 non-bonding groups. Remember that I'm only worried about the non-bonding groups around the central atom. So I see I have a total of 5 groups. And so if I have 5 groups, regardless of whether they're bonding or non-bonding, then I know my electron pair geometry will be trigonal bipyramid or trigonal bipyramidal. Then, based on the ratio between the bonding and non-bonding groups, I can see that I'll have a molecular geometry that is linear because I have 2 bonding groups and 3 non-bonding groups.